In this video, we are going to talk about the quadratic function. Now, the quadratic function looks something like you see on your piece of paper. So you can either have a quadratic that is concave up or concave down. And we'll be talking about this a value soon. Now, the quadratic equation is represented into three forms. The most common is the standard form or the general form. And this is when we have our function written as ax squared plus bx plus c. In this format, we notice that the c is our y-intercept. Another formula which is given in the formula booklet is the axis of symmetry. So you can find the axis of symmetry by using the formula x is equal to negative b over 2a. And this is going to give you the equation of the axis of symmetry. The axis of symmetry will always be x is equal to a number because it always represents a vertical line. Now, another form that we're often going to see is the zero form, or often called the factored form. And this is when we have our zeros. So we have a x minus p and x minus q. In this situation, p and q represent our zeros of our function, or the x-intercepts. And the other equation that we often see is the vertex form. Now, the vertex form is written so that we can clearly see the coordinate of the vertex. So the vertex, whether it be the maximum or the minimum, is the coordinate hk. Now, we can notice that in all of these questions, we have a, and a. Well, this is the a that we have here. So a is the number that's multiplied to the x squared terms. And this dictates if we have a concave up or a concave down. So if it's concave up, that means that we have a positive a. And if it's concave down, we have a negative. And I like to see it as a little either smiley face or a little sad face for positive and negative values of a. Okay, when we're solving questions, often it's going to be really important for us to realize if our function has one solution, two solutions, or no solutions. And this comes from understanding how many zeros are possible when we're solving quadratic functions. And we have three different situations. It's possible for our quadratic to have two zeros. That means that we are crossing the x-axis twice. It's also possible to have only one zero, only one solution. That's when our quadratic crosses the x-axis exactly once, and this happens at the vertex. But it's also possible to have no zeros, so absolutely no solutions. And this happens when our quadratic never crosses the x-axis. Okay, so now we're going to do a couple questions. The number one tip whenever you are doing your questions is every time you're given a function, make sure to graph that in your calculator. So let's look at our first example. We have a diver jumps off a 10-meter high diving board into a pool. The height of the diver above the water is modeled with this function, where h of t is the height above the water measured in meters, and t is the time after the diver jumps off the diving board measured in seconds. How much time passed after the jump before the diver enters the water in the pool? Give your answer correct to 2 decimal places. So first thing, if you're given a function, you have to make sure that we put it into our calculators. So in our calculator, we're going to put our function. We have negative 1.2 x squared plus 1.4 x, and then plus 10. We click on enter, and then we can graph it. Okay, we can see clearly what is happening here. In this equation, we have to understand that t, our x variable, represents time. It can never be negative. So time is always going to be bigger than or equal to 0. So we know that for the graph we have here, we see a quadratic. This position is when our diver is starting to dive. And then h was the height above the water. So the water is represented by my x-axis. So when they ask the question, find how much time has passed after the jump before the diver enters the water, we are looking for the point where the diver crosses the water. In other words, we are looking for the zero of our function. So in our calculator, we go second function trace. Second option is 0. And then they ask for the left bound. So remember, I'm looking for the 0, which is on the right. So left, and then I have to choose right, and then guess the 0 somewhere here. And my calculator gives me the 0 point. This 0 happens at 3.53 and 0. So give your answer in seconds, corrected 2 decimal places. This is happening after 3.53 seconds. Example 2. The Sydney Harbour Bridge is suspended by 2 spans that can be modeled by a quadratic function. The lower span is approximately 503 meters wide and 118 meters tall at its highest point. Develop a quadratic model for the lower span such that one end of the span is positioned at 0, 0. Okay, so in this question, we're told that we can model this with a quadratic function. We're also told that our quadratic function has a highest point. So if it has a highest point, that means that we need to have a maximum. So if we have a maximum, then we know that our quadratic is going to look something like this. So I can start and create a representation for this model. We're told that one end of my bridge of the span is going to be at 0, 0. So if this point is 0, 0, this is this point right here. So that means my bridge is going to go something like this, obviously not to scale. And now we're going to use the information we have in terms of the numbers. 503 meters wide. That means that if I start at 0, 0, I will end at 503. And this is another 0. And then I'm 118 meters tall at my highest point. So the highest point being my maximum point, and this is going to happen at a height of 118. And we are asked to create a model for this. Since it's a quadratic, we can write our model as ax squared plus bx plus c. Notice that we have 3 unknowns that we need to figure out. We need to figure out what a, b, and c is. Now, the easiest way to do this is we're going to have to use 3 coordinates from our quadratic function. And I'm going to show you how to insert everything into your calculator. So already we have 2 coordinates here, but we're missing a 3rd coordinate because we need 3 coordinates for the 3 unknowns. So we're going to use this maximum point. Well, this maximum point, we know the y coordinate is 118 because that's going to be the maximum point. And for the x coordinate, well, the maximum point happens at our axis of symmetry. So the maximum, the vertex, happens at the axis of symmetry. And the axis of symmetry always happens between 2 0 values. So exactly halfway between our 2 0 values. So 503 divided by 2, that's going to happen at 251.5. So my x coordinate is going to be 251.5. So now I have 3 coordinates, and I'm going to show you how to do this with your calculator. In your calculator, we're going to go on to Stats, Edit. List 1 is going to become our x coordinates. I'm just going to short form it. And our list 2 is going to become our y coordinates. And you need to make sure that we put them in order. So if we start with the coordinate 0, 0, we're going to have the x coordinate 0. The y coordinate is 0. If we do our maximum, we have 251.5, and its matching y coordinate has to be 118. And if we do the last one, we should have something like this. So go ahead and put this into your calculators. Once everything is in your calculator, you're going to click on Stats again, Calculate, and you're going to go down to Quadratic Regression. Quadratic regression, we're going to click Enter. Our x list was in list 1, our y list was in x2. We can leave the frequency blank, and we're going to go ahead and calculate. And now we get A, B, and C. So that means that my function can be negative 0.0018 if we round, x squared plus 0.938x plus 0, or you can leave the 0 blank if you want to. Example 3. A rectangular mirror has a perimeter of 260 centimeters. the length of the mirror is x. Find the height of the mirror in terms of x. So for A, we are told that the perimeter is equal to 260. So if the perimeter is 260, that means adding up all the sides put together is going to be 260. If one side is equal to x, then that means that we're going to have this side is also equal to x. And we're asked to find what the height is. So the height, let's represent it as y. Well, we know that the perimeter is going to be 2x plus 2 of the heights. So we can rearrange this so that we have only h on one side. And that's equal to 2h. And then we divide everything by 2. And we get that h. And we get that h is equal to 130 minus x. And this is part A. Next, B. Find an equation for the area of the mirror. So the area of the mirror is going to be x times h. But now that I know that h can be written as 130 minus x, I can simplify the area to be 130x minus x squared. And this is going to be plot a graph of your equation for the area of the mirror showing A on the y-axis and x on the x-axis, and choose a suitable domain and range. Now that I have an equation, I can put this into my calculator. 130x minus x squared, and then I can graph this. Right now, my window is really not suitable, so I can zoom out. Let's zoom out. Okay, now we see that our domain seems to be suitable, but we definitely don't have enough of the y. So I'm going to go into my window and I'm going to change my y maximum. Let's make this 500, a lot bigger, and see what we have. Still not enough, so I'm going to change this y maximum. I'm trying to see what the maximum point is. Okay, we're getting closer. 2,000 was not enough, so let's try 5,000 instead. Oops, not 5, but 5,000. And graph. Okay, so now we see our zeros, which is good, and we see our maximum point. So this would be a good domain and range. To make it even better, we would probably want to change our y minimum so that it's maybe -1. And then we would have a perfect domain and range here with all the relevant information. For D, find the coordinate of the points where the graph intercepts the x-axis. Intercepting the x-axis, that means that we are looking for the zeros. So in our calculator, we can find what the zeros are. We're going to go second function, trace zeros, and we're asked to go to the left and to the right. So if I'm looking for the right zero first, let me get a little bit closer. So this is left, and then I can go to the right of it. This is right, and I can guess. So one of my zeros is 130 and 0, and the other 0 is 0, 0. Next, part E. State which of these two values of x represent. State what these two values of x represent. Well, this represents when you have an area which is equal to 0. So these x values both have our area is going to be equal to 0. Hence, find the equation of the graph, the line of symmetry. The line of symmetry, this happens at the vertex, but it also happens exactly halfway between the two zeros. So exactly halfway between the two zeros, that's 130 divided by 2. So we would have our axis of symmetry is x is equal to 65. Another way you could have done it, second function trace. And what is the maximum point? The maximum point, you're going to the left of the maximum point. And then you're going to the right of the maximum point. And then you're guessing where that maximum point is. And they give you the maximum is 64.9999, which rounds to 65. And part G, state what the equation of the line of symmetry tells you in this context. Now this is super important. In this context, since our maximum is happening at 65 and 4,225, this is telling me that when x is equal to 65, I have a maximum area, and the maximum area is 4,225 centimeters squared. A tightrope connects two elevated platforms which are 50 meters high and 100 meters high. Julian wants to know the height of the tightrope above the ground as a function of distance along it. He knows that the tightrope is 30 meters high at its lowest point, and he assumes the height follows a quadratic function. Find a quadratic model connecting y and x. First, we have a tightrope connects two elevated platforms which are 50 meters high and 100 meters apart. 50 meters high, 100 meters apart. Let's put this information on our graph. 50 meters high, that means that this value is 50 here. And 100 meters apart, that means that this is 100 meters. Next, we're told he knows that the tightrope is 30 meters high at its lowest point. 30 meters high at its lowest point, that means this point here is 30 meters above the ground. What we can do now is we can create some coordinates. So if we know this coordinate is on the y-axis, this is going to be 0, 50. This coordinate here is at 100, but it's still at a height of 50. And then this point here is at its lowest point. These two values have the same y value. Therefore, the axis symmetry needs to be exactly halfway between them. So exactly halfway between them, we're going to be at x is equal to 50. So the axis of symmetry is happening at x is equal to 50. Therefore, my minimum point is happening at 50, and we're told that it's a height of 30. So now we're back in a situation. So we have three coordinates. So I can put this into my calculator to find what the equation is. So take some time and put this into your calculator. Once you have this into your calculator, you can go ahead and calculate the quadratic regression. And we're going to get a model where the function is y is equal to 0.008x squared minus 0.8x plus 50. So that's part A. Part B. Hence, estimate the height of the tightrope above the ground at point P. At point P, we'll notice that it is 20 meters away from the 100-meter point. So this point P is going to happen at 80 meters. So if we know what the x value is, we can replace the x value into our equation, right? So we replace the x value into our equation. So we have 80 squared minus 0.8 times 80 and plus 50. And we're going to get that y is equal to 37.2. So this is the height at point P. And part C, for what values of x is the quadratic model valid? Well, this we're talking about the domain. So what domain makes the most sense in this situation? Well, x can definitely not be smaller than 0, right? And then where does our tightrope end? Our tightrope ends when x is equal to 100. So our domain is going to be x bigger than 0 or equal to, and x smaller than or equal to 100. So you can write it like this. You can also write it as one inequality, right? Or you can write it as words. Example 6. The demand of a certain style of jean is modeled by this function, where D is the number of items sold and P is the price of the jeans in euros. Develop a model for the revenue earned from selling these jeans based on the selling price. So for this question, we have to think about what revenue means. Revenue is going to be how much money we're making, right? So for the revenue, it's going to be the number of jeans we have times the price of each of these genes. And that's going to be our revenue. So the number of genes we have, that's modeled by D. And the price of each of these genes is modeled by P. So I'm just using the variables that are given to us, where we see that D is the number of items sold, while we have P is the price of the genes in euros. So if I write an equation for revenue, well, that's going to be 1,000 minus 5P times P. If we simplify this, we have 1,000P minus P squared. So this is going to be the revenue equation we have. B, use your model to find the price the genes should be sold in order to maximize revenue. Maximizing revenue. Okay, now that we have an equation, let's put this into our calculators. So we're going to change around our window a little bit so we can zoom out to see if we can find anything. Okay, I'm starting to see my other x-intercept. Okay, now maybe I'm going to need a little bit more in the y maximum. So y maximum, let's change that right now. There we go. Now we see a maximum. So we're looking for this maximum value. So second function trace, maximum. We're going to go to the left of it, and we're going to go to the right of it, and we are going to guess the point. And we're told that our maximum is happening when x is equal to 100 and y is 50,000 here. Okay, give the maximum revenue predicted by the maximum revenue is going to be our 50,000. And give a reasonable domain and range for this model. So if we think about our domain is going to talk about the value of P, which is the price. So our price can definitely not be smaller than 0. We don't want to be giving our things away. And then what is our maximum price? Well, we want to be able to make revenue, right? So our maximum price is going to be where we are breaking even. So where our revenue is equal to 0. And I can find that by looking for the 0 on my function. I'm going to look for the 0 which is on the right-hand side, the furthest away. And then I'm going to guess. It's kind of hard to guess. So this 0 is 200. So if the price drops below 200, then we're going to have a revenue in the negative, and we don't want this to happen. So this is going to be our domain. And our range is going to be, we can see from 0 all the way to, we said our maximum revenue was 50,000. So this is going to be the appropriate domain and range for this question.